Okay. Yeah, so first I'll just introduce myself. I'm Wei. This year I'm co-leading, mainly leading the Chudio community at my school, Eric Camber, and one of our main goal is to create a kind of community, a place for students, alumni, and teachers to connect, especially over their passions and interests, and really explore those interests and maybe find their careers. So today, that's what we're gonna do, and just I'll quickly try to introduce you. From what I've looked at, Najm is working on numerical modeling of materials. Right now, he's working as a postdoc at UBC, and he's worked in I think it's Saudi Arabia, um, Arab Emirates, and also previously Montreal.
Yeah,
Okay.
yeah, that's a
Yeah.
yeah.
Okay. So,
Thank you for having me over. Yeah.
okay. Thanks. Yeah. I'm just gonna start. Oh, mama. I'm just gonna start asking questions now. So, what does a typical day in your job look like? What activities are involved?
Oh, okay. So currently I'm a postdoc at UBC, and
Mm,
I'm also an instructor in the maths department.
mm,
And so a typical day starts off with checking off my emails
mm,
and responding to those emails, urgent emails.
mm.
And then I divide my day into two parts. The
Okay.
first part is with regards to research. So that's when I start to focus and try to see where I'm at research, what are my goals are, and then
Mm,
start to develop and work towards my research projects. And then halfway down the day, I switch back to my teaching. Currently, I'm teaching differential equations to undergrad students. So that's
oh,
where I have to check if the students have any questions, maybe design a homework that's coming up or midterm,
mm,
and prepare for the next class. And so if I have a class during the day, then it's I have to go teach that class. But so basically, it's divided into two. There's a research portion where I have to work on a research project, and then there's a teaching aspect as well.
okay. I
Yeah.
see. Yeah. I was actually just using very basic differential equations at school today, but
Oh, okay, nice.
probably definitely not as advanced as that. Yeah. Okay. And you're working remotely right now?
Yeah, currently I'm working remotely from my place. Yeah, home.
Okay. Has that changed anything?
Yeah, it's changed significantly, right? Teaching, for example, was live. I'd go to a classroom, students would be in front of me, and now
Yeah.
teaching is via Zoom. So that's
Mm,
it's a different method. It's got its advantages and disadvantages.
mm,
Um, Research, yeah, it's been almost I mean almost the same because we used to my advisor and I we used to use Skype beforehand as well,
mm,
just to talk, and then we'll be continuing that. So research hasn't been that influenced. I mean, but definitely teaching has changed significantly.
mm. And I guess the like actual programming is actually not very much of the work.
Yeah, so I'm a numerical modeler, right? So I usually use a computer. So what I do, I took my computer from my office at UBC and brought it home,
Mm,
and that's where I mean works. I don't have any experiment aspects to it, so I don't have to go to the lab and do
mm,
experiments. So that's yeah,
that's
quite
nice.
similar. Yeah.
Mm. Yeah, that's actually like my dad. He's he does numerical modeling in geology. Yeah.
Nice.
Mm. And I guess maybe I kind of touched on it in the intro. Um, what's kind of like your story? How did you get into your current position?
Oh, so my dad is a faculty member, and
Oh,
so we used to live on campus
mm,
back in Saudi Arabia, and so
mm,
I always had that passion of becoming a professor one day. So all
mm,
my friends, their dads were professors, so I was
oh,
always in that environment, right?
mm,
So I did my undergrad from Malaysia, and after my undergrad, I went for a master's, and then that led to a PhD. That was quite smooth. And then after my PhD, I wanted to do a postdoctoral fellow. And
mm,
so I contacted the professor here at UBC, and he was interested in my work. And he was looking for someone that with my background, so he hired me, and the department gave me a contract for teaching as well. So
Mm. Were you interested in mechanical engineering for things like learning how machines work or like that kind of stuff?
yeah, I was always interested in mechanical engineering. As a small child, I would play around with like motors and lights and see how
Mm.
batteries connect two batteries together. Um, and so that kind of like influenced me in a way.
Mm.
And mechanical engineering is different from other engineering, especially with regards to electric engineering, for example. In
Mm.
mechanical, you can see things. You can see a
Yeah.
motor running, right? You can
Mm.
see a car moving, right? Whereas in electric engineering, you can't see the electricity moving or something. Or it was
Yeah.
more hands-on. That's why I was inclined towards that direction. Yeah.
Mm. So, for those of us interested, what are some things that like high school students can do right now? Maybe like different courses. I know our school has programming. Um, I think there's also like robotics. And then yeah, what are some things?
Programming is definitely one of them. It's a
Mm.
major topic, especially in the world that we're living in right now.
Yeah,
um, Get hands on, like work on a project, like work on a Sudoku solver, for example, right? That's pretty
mhm,
fun. Try to
yeah,
develop a solver. That's and work on projects. Don't just go textbook based, chapter one, chapter two. Work on a project and you learn while you do the project, right?
yeah,
Programming is definitely one of them. Then for in terms of engineering, I'd recommend hands on projects like
mhm,
DIYs, do it yourself, like projects. We can get small kits and then start building them up.
yeah,
This way, you're having fun and at the same time you're learning, right? Instead of
mm,
just the organic way of opening a book and reading off it. That's not fun.
yeah,
The
yeah,
project that you really like and work on it, yeah, and you
yeah.
learn on along the way, yeah.
I did science fair projects. I think science fair is really good. Yeah. Actually, last year I built a it's like a metal robot, um, and it's supposed to be like a home robot for fighting
Okay,
fires. So it stays in your home like a Roomba, and then
nice, nice,
it like shoots water. Yeah.
nice, nice.
I can definitely say that was much more effective than any textbook.
True,
Yeah.
true, true.
And maybe more specifically for like modeling, I guess things like statistics.
Yeah. So I mean, statistics will be one of them, but modeling, there's two aspects to it. There's a
Mhm.
programming aspect, and
Yeah.
there's the knowledge aspect, right, of that project, right? So if you're doing like data modeling, then obviously you'll need statistics. But
Mm.
if you're doing something sort of like numerical modeling, you need applied mathematics,
Okay.
numerical models.
Mm-hmm.
So yeah, I mean, these are just sidelines that are required on top of the programming
Mm-hmm.
for these type of projects, right? Yeah.
Mm. Okay. And what do you think are some like important traits in your specific job?
Important what?
Important traits.
Oh, traits. Okay.
Yeah.
Um, being an effective communicator.
Mm.
That's a teacher needs to be effective.
Mm-hmm.
Needs to know how to pass that knowledge on.
Yeah.
That's definitely one of them.
Mm.
Um, and then teamwork as well, because research is always teamwork. You got to
Mm.
know how to work with a team, how to
Yeah.
distribute the workload and all that. That's
Mm.
also very important, because if you're not a good team member, then that's gonna slow down the project, right?
Yeah.
Um, and then obviously there's all the technical side as well. Being interested in learning and
Mm.
not being afraid of going into new areas and learning, getting a book and learning a new
Yeah.
direction, right?
Mm.
One has to be very courageous, because it's not easy to learn when you're in research.
Mm. Yeah. Mm-hmm. Okay.
Yeah,
That's great. Thanks. Yeah.
yeah.
And has technology been changing your work like over your career?
My career is quite relatively young,
Okay. Mm.
uh, so it hasn't significantly impacted. But I
Mm.
remember when I was in high school, we used to submit our projects in floppy drives.
Oh, wow.
Floppy, yeah, it was 3.5 MB
Oh,
floppy drives, right?
okay.
And in our university, then we started to use USBs. I remember in my high school we used to use CDs as well.
Oh,
CDs, rewritable CDs. But then you get scratches and all that. Then USBs came.
that's
Now,
interesting.
no, yeah, now no one knows what a CD is, or you don't
Yeah,
see CD-ROMs.
yeah.
So yeah, I mean, from my not from my career, but from my whole life, my
Mm,
educational experience, definitely
mm,
technology has significantly changed
mm,
the way I work, how we transfer data. Now we
mm-hmm.
have Dropbox. USBs are gone as well.
Mm, yeah.
Yeah.
Okay. Um, and maybe some more specific questions now. Um, like, what are some differences between working in industry and university? I guess you mostly have been working in university.
I've mostly worked. I've yeah. I did an internship in my undergrad,
Okay.
but that was a 3 month internship.
Mm, yeah. What other fields, like applications, are numerical modeling used for? I guess one is like geology. That's my dad. And
Yeah.
I think you're working on materials, right?
I material deformation and modeling fracture.
Mm,
That's why I
yeah.
model fracture in the composite materials, and
Mm,
we do some geological as well. I did metals in my masters, and then I
okay.
did composites in my PhD. Yeah. So I model basically deformation, material deformation.
Okay. Mm.
Yeah.
You've been living internationally. How has this affected your work and also maybe more generally?
Oh yeah, living abroad is quite fun. It has
Mm,
its challenges, but you get to meet a lot of people from
hmm.
different parts of the
Yeah.
world. Your friends have, I mean, different come from different backgrounds, so you get to taste a bit of different cultures and different
Mm,
foods and different languages and how people behave. That's always
yeah.
been fun.
Yeah.
Uh,
Yeah.
yeah, and you get to see new places. Yeah,
Mm. Yeah,
so
I
that's
moved here from Ottawa and before that Germany. And
nice.
yeah, that's definitely true. I think Canada's the best place for this. Um,
Yeah,
like a lot of different cultures, and it's really interesting to see so much multiculturalism.
true,
Yeah.
true.
Mm. Um, and maybe what are the pros and cons of numerical modeling compared to experiments?
Oh, that's a very important question you've asked.
Thanks.
uh, in numerical modeling, you can do whatever you want, right? There's no
Mm,
limit experiments. There's limitation where you have to first make that material and then test it. Sometimes it's hard to make that material. You don't have that accessibility.
mhm.
Numerical model, anyone who has a computer can make a model, right?
Yeah.
But then there's a downside to that, that models are sometimes not very accurate, right? And you need to know where the limitations are and what the you have to have an aggressive validation procedure for your model to be very accurate, right? So
Mhm,
that's the disadvantage, that validation and to gain trust in a model is very difficult.
mhm. Okay.
Yeah.
Is there any like cross, I guess, validation or anything with between modeling and experiment?
Oh, definitely. There's always that one
Oh,
section. That's one of the first steps
oh,
before you
okay.
start. You have to validate the model. Otherwise, you can't move forward. Yeah.
Yeah, okay. Can you provide like a successful example of using numerical modeling in like a actual case?
Um.
I guess just like a previous case that you worked on or like
Yeah.
previous problem.
So I worked on uh, I worked on modeling hard biological materials, so mineralized materials, so bones, uh, teeth, seashell. You know,
Mm,
if so one of the questions that I answered was, why is it that when you take a bone and you break it, you'll
mm.
see spikes, you'll see teeth,
Yeah,
right?
yeah.
Whereas if you take a chalk and you break it and there's no teeth, it's just a flat,
Mm.
relatively smooth curve. So what's and then bone is 95% calcium carbonate, which is chalk, right?
Oh,
Yeah. So then why is it that when you break a bone you get teeth?
mm,
That was one of the questions that, and so we had to use numerical modeling to answer that question. And
mm,
what are the advantages and how we can use that to make engineering materials like tougher, because that's a toughening mechanism, right?
mm. That's really interesting. So like
Yeah.
biomaterials kind of.
So if you compare bone with chalk,
Mm,
it's the same. It's almost the same material.
mm,
Right? Even the seashell and the chalk are almost the same material as well.
mm,
But it's a microstructure, and you need models to understand that. And that's one of the important questions that I answered in my PhD was why is it that chalk is so weak and seashells are very tough,
mm-hmm.
right?
Okay.
So that's a very successful example, and what we
Mm,
can learn from nature and to implement them in engineering materials, right?
yeah, that's really interesting. Yeah, I think a lot of us are interested in like biotechnology, including biomaterials. I think that's really like the next step in technology, like combining with biology. Yeah,
Yeah.
that's really interesting. Thanks. So I guess my final question is, what do you love about your work and what do you not like so much?
I the one thing I like about work is flexibility.
Mm,
Um, Research is a flexible career, right?
mm,
I can work at night, I can work in the afternoon, I can work in the morning, right?
mm,
There's no like a fixed 9 to 5 job.
yeah.
Um, I like the flexibility, and also like the fact that every day is a new day. I get to learn new things.
Mm-hmm.
I'm always exploring. I'm always learning, and so
Yeah.
that's very important, right?
Mm,
As opposed to a routine job of 9 to 5, the same thing, right? That's the advantages.
yeah.
Disadvantages are um um what are the disadvantages of my
That's too good.
no no um the thing is projects are, even though you might be very interested in a project, but if
Mm,
there's no funding associated to it,
yeah.
then that project's not gonna continue on. So they're
Yeah.
gonna pull the plug on it,
Mm,
despite the fact that you can love it as much as you want. You can have a lot of passion for it. You can
mm-hmm.
say this might like get us somewhere, but if there's no money attached to it, then it's not gonna run. And
Yeah.
there's there, there are moments where you have to cancel or pull the plug on a project, even though it's not your decision, but it's the reality. So that's
Mm,
prematurely catching canceling projects. I'd say is a disadvantage of this. Yeah.
yeah. And personally thinking about it, like the uncertainty of um, like having to research and innovate and think of new ideas. Sometimes maybe like this, um, yeah, uncertainty is kind of un-
Yeah. Especially now, I mean, all the funding is directed towards COVID research,
mm,
which is important. Which is so that's what we have to plan ahead and see what direction we can take,
yeah,
right?
mm,
And obviously finding new research, making new materials, making new products. It's very difficult. It's
yeah,
not like a overnight thing. It's years. Takes years
yeah.
of effort. Yeah.
Okay, yeah.
Yeah.
Um, yeah, that's all I have. Thanks so much. Do
No,
you
no.
have
Thank you for having me. Yeah.